Okay, welcome back. We're going to be continuing Unit 4 with Lesson 4, and we're going to be investigating the nature of roots. Ultimately, what we're going to be doing in this lesson is that we're going to be using the quadratic equation, which we used in the previous lesson, and we're going to be learning something about that quadratic equation that can help us out in determining the nature of roots. Roots, again, are x-intercepts for our quadratic. So basically we have this quadratic equation, which we learned last time, negative 1 times b plus or minus the square root of b squared minus 4ac over 2a. And we use this quadratic equation anytime we want to find the roots, the value of the roots. And we used to use this method of factoring, and we could still use that method of factoring, but sometimes we can't. And before we would say, oh, it's not possible, the roots don't exist, they actually do. It's just that maybe they're decimals. So if we use the quadratic equation in these three different examples here, we're going to be able to solve for the roots. So the first one that we're going to use is this x squared minus 6x plus 5. So here it is. I filled in my values of b, a, c, and a. That's all I did is I replaced those values. And if we look at this investigation that we're doing here, we're going to see that the only value that's really changing across all three examples is going to be this c value, this positive 5, this positive 9, and this positive 13, right? Everything else, the a value of 1 is staying the same, and the b value of negative 6 is staying the same across these three examples. Because the goal is that we're going to be replacing everything in the quadratic equation, but one part is going to be changing, the part underneath the square root. So if we look, our b for all of them, that 6 is staying the same. And the denominator is also staying the same at 2. The only thing that's really changing because of this changing c value is going to be the part underneath our square root. So if we look at our three different examples, the first part is a positive 16, the second is a 0, and the third is a negative 16. And what we're going to see that when we have a positive value underneath, it doesn't matter what the number is. As long as it's positive, when you do split it up into adding and subtracting that square root, or what's underneath the square root, you'll get two different numbers. So this means that there are two different roots. There's an intersection at 5 and an intersection at 6 for my x values in this parabola. But if I look at the next example with a 0, well, when I add a 0 or subtract a 0, it's not going to change the value, so they stay the same, and both my x-intercepts are at 3. And this unusual one at the end is to show you that anytime you have a negative value underneath your square root, well, guess what? Can you square root a negative number on your calculator? Go ahead and try it. Try to do the square root of negative 16. What does your calculator say? It says error, because you can't square root a negative number. It's just not possible. We've already talked about that in this course. So can you actually complete or find the roots for even using the quadratic equation? No. So we're going to write down that there are no roots. So really, this was just an investigation into determining what the part under the square root has, or what influence it has in the quadratic equation, and really it's a pretty big one. Ultimately, we're seeing right now that anytime we have a positive number, a 0, or a negative number, it can produce three different examples for us as far as our roots or our sketch that we could make of our parabola is concerned. So by looking at this, we can see that our positive number underneath our square root, that is, will produce two different, we're going to call them distinct, real roots. That means that they exist. Now, if I find a 0 underneath this square root, then that's going to only produce one root, or we're going to call it two equal real roots. And we call them two equal real roots because there are two roots. Let's look above here, right? You see, when we add and when we subtract, we're getting two roots, and they're both at 3. So they're equal. So two equal real roots. And if we have a negative value, well, we know that we can't square root a negative, so it doesn't exist. So it looks like something like this. It could be an example of a parabola above or even below the x-intercept, either pointed up or down. So for that, we're going to describe it as no real roots. So here's ultimately what we did. We found out that using this quadratic equation, ultimately there's this part underneath the square root, and we're going to learn the name of this part under the square root. I'm going to spoil it right now. It's called the discriminant. That ultimately this discriminant, the 16, the 0, and the negative 16, I don't need to do the whole quadratic equation. I can just do the discriminant part and find out the nature of the roots or the type of roots if I have to do a quick sketch. So if it's a positive number, you'll have two different real roots or two distinct real roots. If it's a 0, you'll have two equal real roots, so it'll be sitting on the x-axis. And if it's a negative number, well, we can't square root it, so there aren't any roots and it doesn't exist. Now this next part is just basically summarizing exactly what I just said. That the part underneath the square root is called the discriminant, and that we can have three different examples of where we're greater than 0, equal to 0, or less than 0. These are the three examples that I'm looking at here: greater than 0, equal to 0, or less than 0. And ultimately, if I'm dealing with a positive number, I've got two roots. If I'm dealing with 0, they're both the same. And if I'm dealing with a negative number, then we can't find the roots, so there are no real roots. These words right here, two distinct real roots, two equal real roots, and no real roots, are the words that you need to know. Because when I ask you on the test, what's the nature of the roots, or what types of roots do we have, I'm not asking you to give me the number. I don't care that the roots are at 5 and 1, or at 3. I want to know the type of roots. Two equal roots, two distinct real roots, or no real roots. So all we have to use is the discriminant. So let's look at some examples of that. Right now, it's telling me, for example number 1, determine how many roots are in the following quadratic equations. So when it asks me that, it's not saying what are the roots, right? It's telling me what are the types of roots. So what I need to use is the discriminant. So for looking at the first part, I'm just going to use the discriminant, which is the square root, or what's underneath the square root, which is basically b squared minus 4ac. I don't need to do the rest of the quadratic equation. I just need to see whether it's a positive number, a 0, or a negative. So when I do that, I'm going to see that, well, if I replace it, my b is negative 9. Remember to use brackets on your calculator, or else it's going to produce the wrong answer there. Minus 4 times a, which is a 1, times c, which is a 7. And if I do that on my calculator, I'm not going to put the square root sign in on my calculator. I'm going to just say that because I just care about the number. I'll see that the number underneath the square root is a positive number, and it's positive 53. So what's the nature of the roots? Well, a positive number produces two distinct, which means different, real roots. And that's what you would write down on the exam, or for our case, a CPT or a test. Look at our next example here of b. We know that that negative 81 can't be there. That's what the trick has been this entire time. A lot of you have been asking me questions, how do I solve for this quadratic? Basically, all the ones that you've been asking me have been, you have to take that value that's on the other side of the equal sign and bring it over to form a complete standard form for quadratics. So when I take that negative 81 and bring it over, it becomes positive 81. And then we can use our discriminant. So the part underneath our square root, which is b squared minus 4ac, we'll fill in those numbers. The b is 36 squared minus 4 times a, which is 4, times c, which is 81. We'll write that into our calculator, and we'll see that the number underneath the square root is actually a 0. So what's the type of roots? When it's a 0, you have two equal real roots. And if you're wondering what that word real means, it means that basically they're numbers that we can graph on a flat surface, because those imaginary roots do exist, but they're on a 3D plane, so we can't really use them. Now looking at something like this, what form is this in right now? Is this in standard form, vertex form, or factored form? Right now this is in vertex form. I can see that this is my vertex, my h, and my k. That's no good for me. So I've got to use this, I got to expand it ultimately to turn it into standard form, which is pretty annoying. We're going to do x plus 2, and we're going to do that twice because that's the method that we like, even though I showed you guys the shortcut. This is actually a little bit easier for us, so let's just use this. So it's going to be x squared plus 2x plus 2x plus 4. We'll collect the like terms in the middle. Now we've seen this, I don't know how many times, guys. Too many times. Then we have to break the bracket. So in order to break the bracket, we're going to distribute this 4 throughout. We'll collect the constants at the end. That's 16 and that's 7. And now what I've noticed, guys, a lot of the times I'm getting questions from you, which is great, fantastic. But just take a minute and think to yourselves, like, if I can't do it, why can't I do it? Well, it's probably because I have to use another skill, right? So ultimately with this question here, if you were to see it and it was asking you for the type of roots, well, it isn't as easy as what it was before when it's in standard form, right? So you're going to have to do one extra step and convert it from vertex form into standard form, which I've just done. Or you might have to just move over the C value or another value to make it into standard form. But these are basically my 3 examples where I can show you where I'm trying to put in like little tricks and ultimately get you to use the part under the discriminant once it's in standard form. So if I try to use the part under the discriminant, which I know is that b squared minus 4ac, I'm just going to fill in the numbers here. It's 16 squared minus 4 times 23. This ultimately produces a square root of negative 112. And now that I know that it's a negative number, do I have any roots? No. So it's no real roots. This means that ultimately the parabola is either above or below the x-axis and is either pointed up or down so that it doesn't cross. So then I can see here 2 distinct real roots, 2 equal real roots when they're both sitting at the same spot, and no real roots. Did I actually tell you what the value of the roots are? No. I just told you the type of roots or how many roots I'm going to be dealing with. These next 2 examples here, we're not going to do this year, unfortunately, because we're just covering our overall expectations.